In this recording, we're going to do a review for Green Book assignment number 6, which has to do with Intro to Trig and Trig equations. It relates to your companion sheet for session number 4 if you're using that companion paper. First question we're going to look at involves arc length. Okay, the key phrase in here is arc. So if you see that phrase, you know you're going to want to use your arc length. S equals theta r. So pick out the relevant information, hopefully identify that there's a radius of 10, central angle of 4 radians. Central angle has to be measured in radians. Fortunately it is here. It's an easy substitution, just 4 times 10, we've got 40. You should think about what units to put on there, but there are no units on this because the radius is unitless. Our next question involves cofunctions. If you remember, there's pairs of trig functions that have prefix co, like cotangent and tangent, cosecant and secant, cosine and sine. In this case, we've paired up cotangent with tangent. Cofunctions, if you remember, co is like complementary. Their angles are complementary. In other words, they add up to 90 degrees. So again, these are your choices. It's an easy setup. Set the angles sum equal to 90. So it's not that the angles are equal. That's a common mistake. The angles add up to 90. Then it's an easy solve. 5x minus 10 is 90. 5x is 100. X is 20. Our next question involves inverse trig functions. If you'll recall, arc cosine is equivalent to saying inverse cosine. Okay? So this is saying, in the parentheses, what's the angle that has a cosine of root 3 over 2? Well, let's consider a triangle that has a root 3 over 2 in it. So that would be this 30, 60, 90 triangle. And so the angle that has a cosine and adjacent over hypotenuse of root 3 over 2 is 30 degrees. Okay? And of course you could put that in your calculator as well. Inverse cosine of root 3 over 2, you're going to get 30 degrees. Now it's as simple as, well, what's the tangent of 30 degrees? But we have to give the exact value. So we go to our triangle, tangent from your SOHCAHTOA, opposite over adjacent. So it's half over root 3 over 2. We've got a complex fraction. Multiply top and bottom by 2. That gives us 1 over root 3. Rationalize the denominator, by multiplying by root 3 over root 3. And our answer is root 3 over 3. Again, you could check that by typing this into the calculator, of course using inverse cosine instead of arc cos. But you can't really just get it from the calculator because there's no calculator button to turn the decimal into a radical. Okay, the next question involves figuring out what quadrant an angle measured in radians terminates in. Well, as familiar as we are with radians, we're more familiar with degrees. So my first suggestion would be, let's convert this radian measure into degrees by multiplying by 180 degrees over pi. That works out to be 300 degrees. And that's a whole lot easier to conceive of because we're more comfortable in the degree world. So let's create an angle that is 300 degrees, and we know that that goes past 90, past 180, past 270, ends up terminating in quadrant 4. The next question is sort of the reverse. It says take 240 degrees and express it in radians. So we're going to multiply by a conversion factor that divides out the degrees. So I want to get the 180 degrees in the denominator. Again, this is not an equal sign, it's a multiplication. I'm multiplying by a form of 1 because pi and 180 degrees are the exact same measure of angle. Well, that leaves you with 240 pi over 180. All you need to do is simplify by dividing by a common factor like 60, and you've got 4 pi over 3. I'm going to skip the next question and do that in a part B video because this involves trig equations, which we're going to learn at the end of the year. Okay. I'm going to skip number 32 as well because again it involves solving a trig equation. Okay. This question involves determining a trig function. So it gives me a point and it wants to know the value of a trig ratio. Anytime it has this type of situation where it has a point involved, let's make a picture. So let's sketch out a negative 4, 3 point, draw a triangle, and then figure out what are the side lengths. So we've got a triangle. It goes through the point negative 4, 3. So we've got this terminal side here. That's theta, always starting on the positive x-axis, rotating counterclockwise for positive angles. That's alpha, the reference angle. So because we have a negative 4 in the x direction that goes left, that's negative. We have a positive 3 that goes up. Well, you can use a Pythagorean theorem, or you can just recognize the Pythagorean triple. That hypotenuse is 5. Now that we've got our sketch, just a matter of answering the question. That's pretty easy if you know your SOHCAHTOA. So cosine of theta is the adjacent over the hypotenuse. So the cosine is just negative 4/5. In our next question, it gives us a trig expression, and it wants to know which one is equivalent. One way to do so would just be to type each one of these in your calculator. Another way would make a picture. So let's make a picture, a sketch of a 240-degree angle in standard position. I'm going to make a reference triangle out of that, which is 60 degrees. So 60-degree reference triangle has root 3 over 2 as its opposite side, half as its adjacent side, 1 as its hypotenuse. Of course, the x and y are both negative because they're going to the left, the x direction, and down in the y direction. So 240 degrees has the same reference angle as 60 degrees. We're still talking about the sine ratio, except it's negative. The opposite over hypotenuse is negative down in quadrant 3. This question asks, in which quadrant does theta lie? So this is probably a multiple choice question. It says tan of theta is 2.7, so the way to interpret that is the tangent's positive. So I want you to draw out an axis, put your ASTC on there, all students take calculus, and cross out two quadrants that you know it can't be because tangent's positive. Then play the recording. So hopefully you crossed out S and C, because we know if it's positive it could be in the all or the tangent quadrant. Now let's tackle the second clue. The second clue implies that the sign is negative. That's the reciprocal function. Reciprocals always have the same positive or negative sign. So if the sign is negative, well, that means it can't be in the all quadrant. It's got to be in quadrant 3. Thanks for watching.